Okay folks, this is the kind of intro, the skinny for the Watershed Survey Lab. That's the online lab these next 2 weeks, and it's an extension from the Upstream Training Lab. We talked about watersheds, what watersheds are, and now we are going to continue to explore the watershed that we'll be sampling. So if you're doing this lab this week, then next week you'll be actually getting out into the watershed and doing some water sampling. We're going to continue to explore the relationship between the landscape and what we call land cover. That is basically if I dropped you out of an airplane and you landed in a given spot within the watershed, within this big bowl, and you looked around, you're going to see pavement, or you're going to see agricultural fields, where you see forest, and I'm going to talk about the relationship between those variables and the water quality. Okay, so you'll navigate, of course, to Canvas. Right, look at the syllabus, look what group. So if you're in group 2 this week, you'll be working online for the Watershed Survey Lab. So you're going to go to that module. That's what it looks like. You'll see the link to the document. So I think the first thing that I would do is to just download that document. Okay, it's a Word document, so you're going to need to have Microsoft Office on your computer. If you don't have it on there, you have free access when you sign into your email through Office 365. You can actually download and install that on your computer. Call IT if you need help with that. You definitely are going to need Word, Microsoft Word. So you'll download and open that file, okay? And you're going to do all your work for this lab to hand in for next week before your lab. You're going to fill all the answers in, add, screen captures in to this document. This is what it looks like, okay? BIO105, Watershed Survey Lab, and you're just going to kind of follow along with this and fill out this entire sheet here. Okay, now, I'm not going to go through everything because it's just be a waste of your time. What I do want to do is to and this is it. There's this page, questions on here. Insert some photographs that you'll take within our watershed. I'll explain that. You're going to do some modeling of the watershed, okay, on this page. So get started, navigate to this app, okay. Keep in mind there's a good help page if you run into issues on this watershed wiki, okay. But I'm going to start out by going to the actual app. Okay, we did this one time. We did this in the lab where we actually sat down with a topographic map with contour lines and we drew out the boundaries of our watershed. Very painful. Students pretty much hated me by the end of that. But that's what computers are very good at. They are good at looking at maps and looking at the contours, and they're good at mapping the high points of a watershed that all drain into a specific given point. And this is what's so powerful about this application here. So you see here it is, model my watershed. You're going to do launch the app, okay, and it'll pull up a map of the United States. You can play around with this. I really recommend playing around with this, and you can explore around the United States looking at different watersheds. But no, you don't need to know my location. I said last time, we kind of proved to ourselves, one of the biggest watersheds in the United States, probably one of the biggest watersheds in the world, starts down here in the Mississippi River. So we're going to pick a given spot, and we're going to now I recommend this map just shows you a very simple map that has boundaries of states and parishes in Louisiana, and it shows you where the creeks are. If you click on this, it'll show you in more detail where this, so it layers on the individual creeks and rivers. Okay, we're looking for the Mississippi River. Oh yeah, here we go. Clearly we can see the Mississippi River over here. Alright, there's Baton Rouge. This is the point where the bayou Mississippi runs out there. Now, if you want to see what the satellite image looks like, which is interesting, go down in the layer section here, and you'll see this little base maps toggle. Click on base maps, click on satellite with roads, and it will show you the actual satellite image. Alright, so we see here's New Orleans, here's Lake Pontchartrain, here's the Mississippi River, here's the Gulf of Mexico. Okay, so if I wanted to just this is nothing to do with the lab per se. This is just playing around with this application to show you how powerful it is. Get started through delineate watershed. Alright, and then I'm going to click on continental US medium resolution. Alright, and then I'm going to drop my point right here. And now what the computer is doing is coming through maps. It's looking for all of the land area that will drain to this one point. So it's basically calculating the watershed. It's mapping and delineating the watershed that for this specific point. And we'll see this is a kind of labor-intensive process in the for the computer, because right, we see basically from southern New York all the way down to North Georgia, all the way over to Montana, Wyoming, Colorado, parts of New Mexico. This entire area of the continental United States drains into the Mississippi River and flows down through New Orleans. Okay, so that's a really extreme example. Nested within that, there are many smaller, thousands and thousands of smaller watersheds. Okay, we are not in that watershed. Okay, so one of the first things it asks you to do on our assignment here is to choose delineate watershed, the continental US medium resolution, and then we are going to delineate the watershed for the stream on campus where we're going to collect our water samples. Okay, so we go back to our map here, and you can do one of two things. Right, you can zoom in. I recommend, again, kind of zoom in on here and see. I'm going to take, to make this more simple, I'm going to take away the satellite images. Just going to go with topography. And we can see here, right, here is Georgia. Here is Macon. There's Atlanta. Okay, this is the Chattahoochee River. This is the Etowah River. And I said in lab, right, that this river flows down, forms the Coosa, flows over into Alabama, flows down through Alabama. I'm kind of looking at this carefully through Montgomery and then down to Mobile. Okay, so we're up here someplace. This is the Etowah River from here to here. We could zoom in, and we can zoom in. I'm going to keep zooming. There's Canton. Okay, we can zoom in. I can take this rivers away. We'll make it a little bit simpler. Let's see. Okay, we're going to get started. Delineate watershed. I'm going to take those rivers away. Well, I guess it's not going to allow me to do this. So what we can do is just search here, Waleska, Georgia. And now it focuses in for us. Okay. So here's mighty Waleska. can continue to zoom. Put this up. Okay. And there's Reinhardt campus. We're going to zoom a little more. There's the campus. There's Baxter Street. So again, it's a little bit difficult to see exactly where we're going here. So I'm going to go back to the base maps. And I'm going to turn on satellite with roads. And this will make it a lot more clear. Okay, here we go. Here's the Funk Heritage Center. There's the gym. Here's the football, baseball, softball, soccer fields. Here's where we are talking about. So I'm going to drop the pen here. Delineate watershed. All of the land that drains to the point where we do our water sampling. Okay. So here's a watershed. Okay. Here is our watershed. So there is the downstream portion. Okay. So we see the land behind the Dollar General would drain downhill into our creek. The land over by the admissions house would drain into our creek at our point of sampling. Okay, but most of the campus is going to drain downhill into Moores Mill Creek here. So really, when we're at Dobbs, we're not in our watershed. Okay, this will tell you where our watershed is. There are parts of campus that are part of our watershed. Okay, but not a lot of it. So basically, the gym, the parking lot behind the gym, the field where the marching band practices, all of that would drain into our creek at our point of sampling. Okay, so here's our watershed. It's all nicely delineated. Okay, again, it takes forever to do this by hand. The computer does this very neatly for us. Okay, I'm going to zoom in just a little bit. I can just close that out. Okay, and what the assignment asks you to do is to paste the delineated Moores Mill Creek watershed below, showing satellite with roads. So again, that comes in to play here with satellite with roads, and that is going to show us where 108, where Baxter Ave is, so on and so forth. Okay, now how I want to, now this is, you can do this in a number of ways. If I want to get this and put it into this, I'm going to use what's called the snipping tool. Right. Snip, not it, come on, S-N-I-P, snipping tool. Click on this. This is actually very, very useful. Okay, where'd you go, snipper? There it is. So do new snip, snipping tool, new. Highlight the area that you want to snip. Okay. Highlight it, let up. There's the picture that we want to take. And we're going to take that. We're going to go over here. And we're going to paste that. Paste here. My computer does this strange thing. Let's see. I need to go back to here, and I need to open this up again. And as long as I don't know, again, I don't know what's going on here. If whenever my computer has a document already downloaded, I cannot edit it. So let's just hope that this works a little better. Yeah, enable editing. There we go. Okay. So we're going to paste that little baby right here. So we did our snip. We do Control V. Bam. It's working. There's our pasted snip. Okay. And we're going to continue down. It says paste the graph that shows the distribution of land cover classes. We're going to go back to our map. Okay. Here's our delineated watershed. And again, land cover is about what's going on the earth. So we can kind of see here. It's a pretty nice looking watershed. We have some ag fields. We do have some, this is R.M. Moore Elementary School. We do have a little bits of the metropolitan area of Waleska. So if you go over here and you click on land, it gives you a graph of all of the area. What is it covered by? Is it covered by open water? Is it covered by glaciers? Open space, that would be like parks and things like that. Is it covered by developed area? Would be city, suburban type of land cover, and forests and this and that. So we see obviously our watershed in Waleska is largely covered by forest. Okay, with a good component of pasture and hay fields. Okay, so this is what I'm looking for you to paste in there. So we're going to go back to our snipping tool. We're going to do new. We're going to snip out our little graph. We're going to go back to our area here, our little assignment, and we're going to paste in our graph that shows distribution of land cover classes. Okay. Next thing I want you to do is to compare, do the same for the watershed where you grew up. Okay. So we come back to our application. I find it's easier just to hit back. That takes us out. We can zoom way out and just pick a random. I'm going to go back to my home, right, Norwood, New York, and I want to see how does the watershed where I grew up compare to the watershed where I find myself living now. Okay, this is where I grew up. Not to make this about me, but this is a beautiful area. This is Canada. Cornwall. I used to go there to eat Chinese food. This is Ontario. We're getting close to Ottawa as the national capital. Is right here. Okay. So here's my little hometown. Plumbrook, Norfolk. There's Norwood. Okay, I'm going to zoom in. And I grew up somewhere in here. So what I'm going to do, same type of thing. I want to determine, I want to get started. I want to delineate my watershed. Okay, I'm going to again turn on the creeks. I'm going to drop my point. This would have been the creek. I've spent a lot of time on this creek right here. Okay, now it's plugging and chugging. In the background, the computer is calculating the area. All right, high point here near Potsdam. All of the area delineated here drains to the creek near my house. Okay, over here, water doesn't drain to this point. It's going to drain over into this is maybe the Oswegatchie River, right? And versus right on the border here of this delineated watershed. Water flows this way, water flows this way. Water flows over here into the Racket, flows this way into Plum Brook. Okay, so it will now. I want to know again, what's the land cover look like in these two different watersheds? And the computer's working on it here. It's working on it. Okay, but you can both clip the specific watershed. Same thing, use snipping tool. Go here, do new. We don't need a lot of this area, so I'm just going to clip out the part that I need. I'm going to go back to my assignment. Do the same for the watershed within which you grew. Paste the map of the delineated watershed. Alright. Here. And it says to also paste the graph of land cover classes. Okay, so we'll go back. Let's hope this thing still working on it here. So maybe I'll give the computer a little bit less to do. I'm going to say delineated watershed, and I'm going to zoom in, and I'm going to pick a little bit smaller area. I'm going to go upstream into this little bit smaller creek. Should give us a smaller area, because this little watershed is nested within the Plum Brook watershed. Okay, so this, okay, very quickly, it has returned our, again, we go to land, and it tells us that this is what is found in that little watershed in my hometown. And we see, you know, again, I want you to kind of compare these, talk about the differences. Similarities, not a lot of developed area in either. Similarity, pretty good component of deciduous. These are hardwood forests like maple, oaks, so on and so forth. But the big difference here being there's a lot of pasture, lots of cows in my hometown. Okay, so you're just going to clip this, snip this, paste it into your assignment, and answer the questions. Okay. Now, last thing I want to show you guys, this is about modeling to see if the land cover changes in a given watershed, how may that affect the water quality in that watershed. Okay, and so this, actually this application has been used by cities and counties when they are weighing options about whether they want to give permits to build a new subdivision, because one of the implications of a big subdivision is it will, affect the water quality, and then that may cost an increase in the process of cleaning water to provide drinking water. So it would be handy for these groups to be able to model, sort of look into the future and know what that change might look like in terms of water quality. Okay, so we're going back to our little home here now. I'm away from home. Many of us, this is not our normal home, so we're gonna delineate watershed. We're gonna continental US medium resolution. We're gonna drop our point. Here goes the computer. It's working on it. It's bam, there's our watershed. Same thing. Okay, here's our land cover. We already looked at this. Now, what I want to do is we're going to click on this little menu here, model. Okay, we're going to model. Going to select, this is all outlined in that handout that I've just been looking at. Site storm model. Click on here. Okay. Now we go back over here. We want to add changes to within this area. Okay. Add changes. So we're now sort of giving the computer a hypothetical scenario. Okay, and I'm going to say I want to make a new land cover inside of this. So say we wanted to make a medium intensity development. Okay, small lot, single family housing units. Okay, so say I wanted to make the next, well, I don't know, we'll call it the Whitetail Meadows subdivision, starting in the 600,000s. Right, we're going to put that in beautiful area here in North Cherokee County, just an hour from Atlanta. So we're going to click here. We're going to click down there. We're going to click over here. We're going to click over there. We'll go back to the first one and click. Bam. Suddenly we have made a huge subdivision. And again, the question here being, how does that change if this happened and we continue to monitor the water quality in that site? How might that be affecting our water quality? So we're going to go to compare. Okay, and this is pretty nifty. I like this. It shows us for these certain variables, for both the runoff and the water quality, it compares our current conditions, what is on the ground in Waleska 2020. Right? Again, mostly forest, some open pasture, some Dollar General, some low intensity development. It compares it to basically if everybody moved out and all the forest grew back and we tore out all the roads and we reverted back to forest, and then it compares those both to Waleska with a subdivision added in there. Okay, and it tells us, right, how that's going to affect things. If we let it grow back in forest, right, there are, if you look in the water is going to be much more clear. There will be many fewer suspended solids. These are soils and things that get into the water and give it that muddy looking appearance. Right? We're looking at those nutrients. We talked about nutrients, things like fertilizers and all of these things from failing septic tanks end up in the water and raise the level of those nutrients, nitrogen, phosphorus. So back on our homework sheet, you're going to fill this out. For the forested, the current, and the new scenario, what are the total suspended solids, the total nitrogen, and then the runoff, right, which would be, we'll go back to runoff. This is the volume of runoff, okay? Does this make sense? Yeah. Because if we look at the budget between these three scenarios, right, the big difference is if it's forested, most of the water infiltrates the ground. It percolates down into the soil and is locked up in the soil and slowly drains down into the creek. Versus if you have a lot of new roofs and new driveways and parking lots, when the rain hits the ground, it runs across the surface and quickly in a big pulse runs into the creek. Okay, so that is what I'm asking for in this section. Okay, and that shows you how to do that. You can rewind this and watch it again and again, and then I want you to just answer these questions. Go out into our watershed, take a picture of a source of fecal coliform, take a picture of impervious surfaces within our watershed, and paste those in. Okay, so that is the online assignment for the week. Okay, and I hope that this clarifies some things for you, and we will see you next week if I can figure out how to stop this thing.